myself Dr. Priti Jagwani. I am an associate professor from the Department of Computer Science, Arbhat College, University of Delhi. So in this series of artificial intelligence, in the initial couple of lectures, we have established the motive behind this series. That is, it is all about the study of intelligent agents, and we have also seen what actually artificial intelligence is and types of agents also we have learned through. Today's topic is about learning agents. Now, when we say learning agents, this is actually a kind of a similar sounding word when we talk about this is similar sounding to machine learning. Now, this is, we can say, a basis, or this is kind of a bridge between the machine learning and the artificial intelligence, because machine learning is also about study of these agents who can learn on on themselves. So basically, learning agents nowadays, we can call it as a preferred method for creation of a state of the art system. So if you want to create new systems which are actually we can say state of the art system, so your learning agent could be, or learning agent is actually a preferred method, because learning, when we talk about, it allows the agent to operate in an initially unknown environment and to become more competent than its initial knowledge alone might allow. So this is actually I can say this is also the fundamental concept behind machine learning, that we need to evolve those machines which are which are able to learn from their own circumstances and from their kind of initial with the help of their initial knowledge and the new circumstances and their patterns, or their models, we can say, they'll become more competent or more smart. So that is what the machine learning is. Here also your learning is actually how an agent is going to behave in an unknown environment or in a situation which has not previously occurred, and every time within learning it is able to perform in an optimal, in a more optimal way as compared to the previous scenario. Now, when we talk about learning agent as an component, we can see that there are four conceptual elements which are able to coin, or which are able to structure, which are able to show in a learning agent. So, what are these four components out of which this a learning or any learning agent is going to be designed? So, the first important component of a learning agent is a learning element. The second component is the performance element, the third component is critic, and the fourth component is the problem generator. So, with this four conceptual components, we can create our learning agent. Now, let us see what is the what we can say, what is the individual functionality of all these four components and how they evolve or how they work in together in order to make a learning agent. Now, when we talk about their working strategy, so first of all, let's know we are aware about the two terms which are perception and action. So, the agent perceives its environment and takes an action through its performance element. Now, in this learning agent, there is also a component which is feedback, and that depends on the critique. A critique evaluates the outcome of the action and provide either the reward or the penalty. So, reward in case your outcome is kind of promising, or outcome is positive, or outcome is good, we can say, and penalties if it is your outcome is not up to the mark. So, a critique is there which is going to evaluate the outcome of the action, provide the feedback, and then accordingly either it rewards the agent or it kind of we can say penalize the agent. Now, next comes is learning. Now, learning element here is going to use this feedback to update the agent's internal model or even the knowledge base which agent is having. So, whatever kind of feedback is given by the critique, that feedback is used to update the agent's model, and that's we can here we can say that with this updation in its knowledge base or internal model, your agent is becoming more and more smart with every kind of exploration. Now next is the problem generator. So problem generator is the component which talks about the new actions which are to be tried in order to ensure that the agent discovers better strategies. So basically when we talk about the working of the learning agent, we are going to deal in the perception and action, the simple concepts of perception, which is perceiving its environment and taking an action through its performance element. But apart from this perception and action, there is a mechanism of feedback which is given by the critique, and with the help of this feedback the agent's internal model is getting updated every time, and here is the learning component is introduced. And after this there is also a problem generator besides this, which suggests the new actions to try, ensuring that the agent discovers better strategies. Now if we want to kind of have a look in this whole learning agent with the help of a figure, so figure is available here. So as we have seen other agents, other intelligent agents we spoke about in the previous lectures, we learned them. So one side we have environment, another side we have agent, and sensors and actuators are the normal components which we have kind of already studied. Now here what are the different components? So 4 components which you can see are different here, or we can say the major conceptual components behind or in a learning agent. So one is the critique, another one is the learning element, performance element, and problem generator. And how these 4 elements are going to interact, that is being shown with the help of a figure. So sensor is actually collecting the perception from the environment, and then kind of with the help of performance element the actions are going to be kind of done with the help of actuators. Performance element is there to evaluate the performance. Whatever knowledge is being kind of generated by the performance element is given to the learning element, and then this learning element is actually doing some changes in the internal model or the knowledge base, and those changes are kind of again we can say reflect back to the performance element. That means now your performance is kind of, or the agent's performance is actually improving with every step. Critique is actually giving a feedback to the learning element, and here is a problem generator which is going to give which is going to get some learning goals from the learning element, and problem generator is also interacting with performance element. So critique is there to provide the feedback, problem generator is going to give kind of new problems to try on, learning element updates the internal state of the agent, and performance element is there to kind of evaluate the performance. So with the help of these 4 components and their intercomponent interaction, this whole learning agent actually works the way it should, that it should learn with every new state, or with every new kind of we can say simply we can say every new kind of data or the situation. Now the most important distinction between the learning element and the performance element is the learning element is actually responsible for making improvement, while the performance element is actually responsible for selecting the external agent. So kind of different responsibilities or different functionalities. Learning element makes the improvement, performance element selects the external agents actions, sorry. So performance element selects the external actions. Also the performance element is something related to what we previously considered to be the entire agent, in the sense when we were studying about the intelligent agents, we study that the intelligent agent or any agent we can say, it takes the percept and decide on the action. So this is what your actually performance element is, but here the learning element is using the feedback which is given by the critique on how the agent is doing and determines how the performance element should be modified to do better in future, and that is done with the help of the feedback which is kind of given by the element critique. Now, the design of the learning element actually depends very much on the design of the performance element also. Given an agent design, if we talk about the learning mechanism, that learning mechanism can be constructed to improve every part of the agent, or we can say every single part of the agent. The critique tells the learning element how well the agent is doing with respect to a fixed performance standard which is having some different we can say performance metrics over there. Now, every component here in this, whether it is critique or a problem generator or a performance element or even a learning element, are necessary. Critique, if we talk about, is necessary because the percept themselves provides no indication of agent success, that whether agent is doing good or bad, or whether agent is becoming successful or it is kind of unsuccessful. But critique is something which is going to kind of provide this indication or provide the indication of the agent's success. Problem generator is responsible for suggesting the actions that will lead to new and informative experiences. So, whatever new actions are to be tried, that are being kind of suggested by the problem generator. So, we have seen this learning agent and its concept along with its elements, 4 elements with the help of a figure. Now, if we want to make this whole design conceptually very clear, let us take the example of an automated taxi. So, here the performance element in case of an automated taxi consists of whatever collection of knowledge and procedure the taxi has selected for its driving action. So, that is what your performance element in case of automated taxi is. Now, taxi goes out on the road and drives using this performance element. A critique is something which is observing the world and passes the information along to the learning element. So, critique is actually kind of interacting with learning element also. So, for example, after the taxi makes a quick left turn across 3 lanes of the traffic, the critique observes that the kind of other side drivers are actually getting angry, or the shocking languages are used by other drivers. So, this actually kind of an indication that no, this is not the move to be kind of made next time. So, now your critique has observed it. So, critique, when it has observed this, now this is going to be kind of given as a feedback to your learning element, and from this experience your learning element will be able to formulate a rule saying that this was a bad action or this was an undesirable action, and the performance element is modified by the installation of new rule. Now, that new rule could be that kind of this kind of quick left turns across the 3 lanes of the traffic is suddenly a bad move, or it is kind of an undesirable movement. So, whatever movement your taxi is doing, whatever action your taxi is doing, your critique component is observing it, and after observing there is an we can say evaluation of whether it is a good movement or it is a bad move, whether the kind of learning agent is successful or kind of unsuccessful in a manner we can say, and then according to that percentage or according to that measurement of success, your learning element is able to formulate the new knowledge that whether the action which has been just taken is actually a bad action or it is a good action, and the performance element is modified accordingly. Now, here we in case of this automated taxi, we understood the critique, we understood the kind of learning element, and we have also with this example we have also seen how performance element is going to behave in this case particularly. The component which we are left with is the problem generator. Now, let us see in the case of automated taxi how this problem generator is going to act, or what is the functionality of this problem generator. So, problem generator here in this case might identify certain areas of behavior in need of improvement and suggest experiments. So, for example, such as trying out the brakes on different road surfaces under different conditions could be new problems for the learning agent or for the automated taxi agent, and according to these new problems which are actually kind of given by the problem generator, the behavior is going to be we can say optimized in the upcoming scenarios or for the future actions. So, what all kind of improvements and experiments your problem generator may suggest, that how you are going to kind of apply the brake on the different road surfaces under the different conditions. So, for example, the taxi is going on a highway with a speed of, let's say, kind of 80 kilometers per hour. So, how a brake is to be applied, or it is kind of going on on a busy road in a crowded city, we can say, then there is kind of a different way of applying the brake. So, all these can be kind of suggested experiments which a problem generator might evolve with, and it can be put in up as the new actions to be tried on. Now, if we talk about the learning agent, so we have seen what are the different components, what actually learning agent is, and how these different components, or how your actually the learning agent is going to work. Now, let us move on to the key characteristics of these learning agents. So, the first characteristics of this learning agent is adaptability, because here we have the name suggests that it is an agent who is able to learn on itself. So, that means it can handle dynamic and unfamiliar environment on the basis of because problem generator has thrown so many problems which are to be kind of tried out. Then we have performance element, which is going to kind of the critique is there, which is going to see how it is being how your learning agent is performing. So, it can handle the new, unfamiliar, unseen environments, it can handle so many dynamic environments also. Then the next key characteristics is self improvement. Your learning agent gets better at task with experience similar to humans. So, as as we as human beings learns with the experience, so is your learning agent. It gets better with it gets better at its own task with every kind of experience. Then the third key characteristics is autonomous. So, your learning agents are actually kind of autonomous, or they operate in an autonomous way. That means they learn and adapt the situations without, I will not say without human intervention, but yes, definitely without constant human intervention. A complete and a constant human intervention is certainly not required when we talk about the learning and adaptation in these learning agents. So, your learning agents are good at adaptability, they are able to do self improvement, and definitely they are autonomous also. Moving next on. So, for example, what all could be the examples of these learning agents. So, one example in order to understand the whole concept we have seen, which is your automated taxi. Now, other virtual assistants. So, for example, Alexa, that's a virtual assistant, and it learns your music preferences with every time either you are going to select a particular piece of music or you are going to reject it. The critic is going to observe that yes, whether you have taken it or you have rejected it, and accordingly your music preferences are being kind of we can say changed, or we can say this is kind of a learning which your Alexa or any virtual assistant is kind of taking up. Then any game or game AI where the characters learn to navigate onto different levels more efficiently on the basis of previous experiences is another example of game AI. Then if we talk about the another example, which is robotics. So, robotics is also also example of a learning agent. Here the agents, which are nothing but the robots, they are learning or they learn to grasp the objects through different hit and trial methods, or they learn to grasp the objects through trial and error method. So, ultimately we can say that your learning agents embody the concept of machine learning, evolving from basic functionality to sophisticated intelligence through continuous interaction and through continuous feedbacks. And this is what kind of we can say a gap or a bridge, even not a gap, but a bridge even between your AI and the machine learning domain. So, here the learning agents, they are going to embody the concept of machine learning, and that this concept of machine learning can evolve from the very basic functionality, and it can range up to a very sophisticated intelligence system, and this has happened with the help of continuous interaction and feedback. Now, please recall our previous lectures in which we have kind of studied our intelligent agents, or we talked about different agent programs. Just to help you recall those things, we have learnt about simple reflex agent, we have learnt about the model based reflex agents, then there were goal based agents and utility based agents. So, all those agent programs as consisting of various components we talked about. Now, various components were there, and the jobs of those components is to answer the questions which we have written in the structure of those agents. What were those questions were? What is the world like now? That indicates that what is the current status of the world. What action should I do now? That means selecting the appropriate actions by the agent. And what my actions do, that means how it is going to affect your environment, or how your environment is going to be affected by this set of actions which I am going to perform as an agent. So, we can place these representation along the line of increasing complexity and expressive power. So, what kind of representations of these agents we have? So, we have atomic representation, we have factored representation, and we have structured representation. So, three kind of representations of these components of these agent components we can say. Let us see how or what actually these different component representations are. So, when we talk about the first one, which is the atomic representation, here each state of the world is indivisible, because we are talking about the atomic representation. That means it has no internal representation, which is no internal structure which is to be kind of we can say required to be represented. Now, for example, consider the problem of finding a driving route from one end of a country to other via some sequence of cities, or we can say kind of this is something similar to our classical problem of traveling salesman problem, although the goals and objectives may differ. But here the problem, or we can say simply we can say it as a route finding problem. So, for the purpose of solving this problem, it is actually sufficient to reduce the state of world to just the name of the city. So, let us say this is Delhi, this is Kolkata, and we are in a single atom of the knowledge, we can say a black box, whose only discernible property is that of being identical or different from another black box. So, let us try to understand this atomic representation with the help of a figure. So, here is an atomic representation in which we have two different we can say component, and there is a state. That state is actually a black box with no internal structure, and we can say we have two different black boxes, or a state which is a black box having no internal representation. So, this is what your atomicity is, or how this is how we are going to represent atomicity. Now, consider we can say a higher fidelity description of the same problem when we are going to move from atomic representation to factored representation, we see that the factored representation splits up each state into a fixed set of variables or attributes, and each of which can have a value. In the previous representation, which was the atomic representation, your states are not divisible, they are bind up in one component. So, because of their non-divisibility, we call them as the atomic one. So, when there is a high fidelity description for the same problem, where we need to be concerned with more than just atomic location as one city or another, we might need to pay attention that how much fuel is left in the tank for traveling, what are the current GPS coordinates, whether or not the oil warning light is working or not, how much spare change we need to have for the toll crossing, what station is on the radio, and so on. I mean, like so many other factors. So, even if we are kind of representing a state not as a black box with invisible internal structure, if we are going to represent a state with a higher fidelity description having so many components, that comes in the picture as the factored representation. So, this factored representation, if you can see here, it is on the screen, a factored representation is given. So, factored representation, a state consists of a attribute values or maybe a vector of attribute values that can be real valued, boolean values, or any of the fixed set of symbols. So, a state is not just being kind of depicted in the form of a black box whose internal structure is not visible or not accessible. Here you can see that a state consists of so many attribute or vector of attribute values, and these values can be very different. So, this is what your factored representation is. So, with factored representation, we can also represent uncertainty. For example, ignorance about the amount of gas in the tank can be represented by leaving that attribute blank. And the actual real life application or actual AI applications of the factored representation includes constraint satisfaction algorithm, which we are going to cover in our upcoming lectures. Moving on to the third and the last representation, which is we can say is the structured representation. So, a structured representation, if we look into here, a state includes not only the attribute of values, but the objects, each of which may have their own attributes of its own, as well as the relationship to other objects. So, now let me give you an example here. So, a structured representation in case of AI problems underlie relational databases and first order logic. That is also we are going to study that. So, a factored representation is unlikely to represent kind of we can say if there is a truck ahead which is going to kind of taking back into a dairy farm and its driveway is blocked by a loose cow. So, this kind of pre-equipped attribution with a value true or false is actually missing in factored representation, which we can kind of imply or which we can represent using a structured representation, because in that we can say your cows are the objects or the trucks are objects and their various and varying relationships can be described explicitly. So, these structured representation have objects, each of which maybe have their own attributes and the relationships among them. So, in this lecture we started with the learning agent. We understood the whole concept of learning agent with the help of examples, and then we moved on to the different representations of the states of the agent. One was the atomic, then there was factored, and the final and the complicated and the most complex was the structured representation. All the three we have seen in detail. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.